Okay, so for this problem, we are going to find the derivative of y equals sine inverse of x. So I'm going to walk you through like the proof of the derivatives, and then I will show you how to memorize them. Okay, so the derivative of y equals sine inverse of x. The first thing we're going to do is rewrite this without an inverse, because I don't know how to take the derivative of an inverse yet, but I do know how to take the derivative of just sine. So let's undo our inverse by taking the sine of both sides. All right, now when I do that, that cancels, and I just get sine of y is equal to x. Okay, now this I can take the derivative of using implicit differentiation. So the derivative of sine is cosine of y. Oops, not cosine times y, cosine of y, times the derivative of y is y prime, and the derivative of x is just 1. Okay, so let's solve for y prime. I get y prime equals 1 over cosine of y. Okay, so here's the thing. What is the cosine of y? Well, let's draw myself a picture of a triangle, and we're going to use SOHCAHTOA. Sine of y, so sine of some angle y is equal to x, and we'll call that x over 1, right? So sine is opposite over hypotenuse. So the opposite side would be x, the hypotenuse would be 1. Now, if I'm finding cosine of y, cosine would be adjacent over hypotenuse. So I need to know what the adjacent side is. But I can solve for that using Pythagorean theorem. So I'll call that like b for now. So b squared plus x squared is equal to 1. B squared is equal to 1 minus x squared. Take the square root. Technically, when you take the square root, you have to put plus or minus. But these are sides of a triangle, so they're going to be positive. So y prime is equal to 1 over adjacent over hypotenuse. So the adjacent side is root 1 minus x squared, and the hypotenuse is just 1. So root 1 minus x squared. And we are not going to rationalize, just leave it. Okay, so that's the derivative of y equals sine inverse of x. First thing I did was I got rid of my inverse by taking the sine of both sides. Then I set up a triangle. I took the derivative using implicit differentiation. I made a triangle, and I used SOHCAHTOA and Pythagorean theorem to solve for the cosine of y, and then I just plugged that into my formula. Let's do the same thing with secant inverse of x. So take the secant of both sides. Secant of y is equal to secant of secant inverse of x. Secant of secant inverse, they undo each other. So I get secant of y is equal to x. Let's take the derivative using implicit differentiation. The derivative of secant, SST, the derivative of secant is secant tangent. Times the derivative of y is y prime. Derivative of x is 1. So I get y prime is equal to 1 over secant of y tangent of y. Okay, now we're going to set up our triangle. Okay, so y is our angle, and we're going to figure out what side is x, what side is 1. All right, so secant is x over 1. Now using SOHCAHTOA, cosine is adjacent over hypotenuse, so the reciprocal secant would be hypotenuse over adjacent. So my hypotenuse is x, and my adjacent side is 1. Okay, so again, secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Then use the Pythagorean theorem to solve for that third side. So 1 squared plus b squared is equal to x squared. B squared is equal to x squared minus 1. So b is equal to root x squared minus 1. Okay. All right, and then y prime is equal to 1 over. Now, secant of y, I already know, is x. But here's the deal. It's the side of a triangle. It must be positive. So we're going to go ahead and force that to be a positive number by taking the absolute value. And then the square root of x squared minus 1 is already positive. I've already chosen to make that positive. So we're good there. And then this is the derivative of secant inverse. So again, take the secant of both sides. Use implicit differentiation to solve for y prime. Use a triangle, Pythagorean theorem / SOHCAHTOA to solve for that third side, and then plug that in as tangent. So secant is absolute value of x. Tangent, I think I just glossed over this. Tangent is opposite over adjacent. So root x squared minus 1 over 1 is tangent, opposite over adjacent. Okay, and then how do I memorize these? So let me write out the answers first here, and then we will talk about patterns we see. So derivative of sine inverse of x. Actually, you know what? I'm going to do this at the same time. Tricks to remember. S, T, S. Notice what that we have our S's and T's, our sine, tangent, secant. We've got our co-functions on the other side. Okay, cosine, cotangent, and cosecant are going to be on our right-hand side. So that's important. So STS. All of these will be 1 over. So if you looked at the two we just did, we had 1 over and 1 over. So these are all 1 over. The S's stand for square root, and they also stand for subtract. So the S's stand for a square root and a subtraction symbol. Okay, I'm actually going to move that over a little bit. Okay, the T looks like a plus sign. Looks like a plus. So tangent has a plus. All right, then we're going to fill in some more ones. Sine comes first, so the 1 comes first. And then it's 1 minus x squared. Tangent is going to be 1 plus x squared. And then secant inverse is going to be, you're going to switch the order of sine inverse. It's x squared minus 1. So remember that sine comes first, so the 1 comes first. And then secant is going to be the opposite. Okay, and then here's your final thing, because remember we had this like absolute value on the outside of secant. So it's C, you can't forget absolute value of x. So secant, C, you can't forget the absolute value of x. C, you can't forget. So these are derivatives of our trig inverse functions. Now, what about the cos? So I want you to think to yourself, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. What's the derivative of tangent? Secant squared. What's the derivative of cotangent? Negative cosecant squared. So the derivative of cos are always negative. And then the derivative of cosine is actually the same as negative sine inverse. I know it's weird, but if you memorize the left-hand side, then you also have the right-hand side memorized. You just have to remember that the derivative of a co-function is negative. So the derivative of sine inverse and cosine inverse are the same except for a negative. Derivative of tangent inverse and cotangent inverse are the same except for a negative. And the derivative of secant inverse and cosecant inverse are the same except for a negative. Okay, so again, you're going to remember that it's always sine, tan, secant, STS, square root, and subtract. The S's stand for square root and subtract. The tangent, T, kind of looks like a plus sign, so it is plus. Sine inverse comes first, so the 1 is first in the square root, so it's 1 minus x squared. Tangent inverse doesn't matter. 1 plus x squared is the same thing as x squared plus 1. And for secant inverse, it's x squared minus 1 inside the square root. But C, you can't forget that there's an absolute value of x